Good day to everyone. So we are from Group 2 and doing the project about smart hospital bed system. And this is my group mates, Benedict Yabasing, Kevin Lee Junkins, and me, Ko Jiaxing and Lim Yubins. So first of all, let us going to introduce what we are going to present. First is introduction, architecture diagram, services used, and also the demonstration of the cloud service that we use. So let us going to talk about our introduction first. So why the smart hospital bed is being invented? So smart hospital bed actually being invented is to provide patient-focused treatment by enhancing patients' outcome through the incorporation of technologies into the beds, and also aims to improve the operational efficiency and cut costs in an increasingly challenging healthcare environment. So due to the advance in technologies, the smart hospital beds actually can enable integration of sophisticated monitoring and tracking system into them. And in addition, smart hospital beds also aims to cater the ongoing trends towards connected healthcare and collecting and analyzing data on patients' health and treatment outcomes. And this smart hospital bed actually is developed in the early 2000s and integrated sophisticated sensors and monitoring system into them, like what I mentioned just now. And due to the invention of these smart hospital beds, so some companies like Striker Corporations, Hero, and Linux Groups began developing and marketing their own systems. As of now, smart hospital beds actually have evolved and having advanced monitoring system which allow real-time tracking of vital signs and patients' movement. Some data like electronic medical records (EMRS) is also integrated into smart hospital bed technologies in order to make the hospital site more convenient in retrieving patients' data and their disease situations. So now I'm going to talk about our project objective. So our proposed solutions objective actually is to develop an AWS cloud system embedded into hospital beds that can detect if patients are absent from the hospital beds at the right or wrong times. And for the second objective is in the same system, but we add on to add some alerts to medical personnel if that condition of a patient suddenly plummets, like their temperature suddenly higher than 38.5 degrees or 38 degrees Celsius. And our last objective is to develop an AWS cloud system embedded into the hospital beds that can record the status of the patients and display their information. So what is our proposed solutions? Actually, our proposed solution is going to have two main tasks. So for the first task is going to use the IoT core, which can retrieve the data sent by IoT device and quickly send a notification to specific personnel via Amazon's SNS if unusual activity is detected and happen to the patients of specific beds. And the second task is to visualize the patient's data with Amazon QuickSight and conduct a machine learning while Amazon SageMaker to predict their health status based on some data collected by us, like the sleeping posture, temperature, and also the disease that caused them going to hospital. So now let us going to explain for our architecture diagrams. So here is our architecture diagrams. First, all the data will be collected by the smart bed with IoT sensor, which is the IoT device, then sent to the Amazon IoT core. Then, if there is some unusual activity or unusual data is detected, so the Amazon simple notification service, Amazon SNS will be triggered and send push notifications to the specific personnel. And then, since IoT core is not a not a database to collect data, so the data collected must be sent to Amazon DynamoDB, which is a NoSQL database, and then sent to AWS Group. Then AWS Group will be sending it to Amazon S3. So further explanation will be taught in the further slides. So from Amazon S3, Amazon Athena actually will retrieve data from Amazon S3 to analyze it and then visualize the result through the Amazon QuickSight. And then for Amazon SageMaker will also retrieve data from Amazon S3, then take some data from them to build, train, and deploy the models. So while the model is deployed, the model will send back to the IoT device, so can like make some health status predictions on and also the model will be saved into the Amazon S3 as a backup. So now we are going to talk about the services that we use. So the first thing is the AWS IoT Core, because AWS IoT Core actually is a platform that for connecting and managing internet-enabled devices, which is connecting our IoT Core with the IoT device, which is our smart hospital beds. And for the Amazon Simple Notification Service, SNS is actually a messaging service for sending push notification and SMS and even email to some specific personnel. Like for our condition is if the patients have higher than 38 degrees Celsius temperatures, then the notification will be sent to the medical personnel. Or even if the patient is not on beds at the specific times or the wrong times, then it also will send a push notification to the specific personnel to notice that. So for Amazon DynamoDB, is actually a full managed NoSQL database service. So for us to store all the data collected by the IoT device. So Amazon S3 is actually a cloud-based storage service for us to store the objects and files. And due to we are going to use transfer data from DynamoDB to AWS, Amazon S3, right? So AWS Glue is used. So AWS Glue is used as a fully managed ETL service for data integration. So ETL actually means is extract, transfer, and load. So means I extract the data, the information from DynamoDB, then I transfer and then load back into Amazon S3. So actually why Amazon S3 is needed, because Amazon S3 is needed for the further service like Amazon SageMaker and also Amazon Athena. So for Amazon SageMaker is a platform for us to build, train, and deploy machine learning models. So for our machine learning models actually is to predict the health status of the patients based on their sleeping posture, their temperatures, and also the disease. Then for Amazon Athena, we will be using the collected data and do some analyzing on it. So actually Amazon Athena is a serverless interactive query service for analyzing the data in S3. So while the Amazon Athena successfully analyze the data, then it will send to Amazon QuickSight, a cloud-based business intelligence and data visualization service to visualize the result for hospital site to monitor the patient's conditions. And that's all for the services we use for these proposed solutions. And now we are going to have some demo on the services that we propose.
Before we actually go into how we set up the AWS instances, I would like to talk a bit about how we simulate the data. So over here, you can see that we have the devices. So 5 devices in total. So client ID we have, and the certificate path, the private key path, and also the topic that it publishes to. So and then now moving on, we have the data that we want to generate. So for example, we have the is patient on bed, the posture, the temperature, the health status. So we simulate this data, and then we store them in a JSON structure, and then we publish to their individual topics right over here. So here we actually get the endpoint, the certificate, the private key of each individual device, and then we publish them to the topics, the relevant topics, which we will set up in IoT Core. Now, before that, we need to actually store this data in somewhere. So we choose DynamoDB. So we actually need to route this data to DynamoDB. So first, we would go to IoT, AWS IoT console, and then we would like to create things first. So in the things, we can create our devices, which we can link to. So thing is actually represents the device, the IoT device in AWS IoT. So for example, we name our device Smart Hospital Bed 07. So this is, we add one more thing to it. And then here we actually can select what certificate we want. So for now, we actually auto-generate a new certificate. But if we have our own certificate, we actually can choose to do so too. Now we would like to auto-generate a new one. And then here we need to attach a policy to this certificate. So IoT policies actually grant or deny access to AWS IoT resources. So be it connect, publish, or all of them. So I'll show you in a moment. So all right, let's say we create policy. Right, we give our policy a name. All right, let's call it smart policy, and then we have policy actions. So over here, as I mentioned, we can select what kind of policy, what kind of action we want to attach to this policy, be it whether if only connect or publish or receive. And here we choose all AWS IoT actions just to showcase what we can do. And then we create this policy. We also need a policy resource. Now we already have a policy already created, Smart Hospital Bed Telemetry policy. So here it has its policy RN, and then our policy action is set to all. We can also build this in JSON. So the effect is allow actions, all of the actions, and then resource all of the resource. Now we select this policy, and then our device is actually created. So to store this data from the devices, we need to go to DynamoDB. So first we have to go to tables in the DynamoDB console, and then we create a new table. So let's say we give our table name bed sensor table. All right, now we have to put the partition key. So the partition key, we set it to device ID. So it's sort of like a primary key. And then for sort key, we want to, it's optional, but we want to able to sort our data using datetime. So we'll put in datetime over here at the sort key. And then if everything is okay, we create the table. And here you go, we have our table here. All right, now we have to go and set up the IoT core to route this data to the table, to the DynamoDB table that we just created. So using this, we can actually use rules, message routing under the console, rule, and then we can create a new rule. So let's say we name this rule, bed sensor rule, and then we click next. And here you can see the SQL statement. So we actually select the attribute from whichever topic if they have any condition. So over here, we want to select all the data that is transmitted by the device. So device ID, date, time, temperature, and so on from the topic. So the plus here, you can see the topic means it gets everything behind that forward slash. So hospital bed sensors 1, 2, 3, 4 for all the device, every topic. So when the SQL statement runs, if it finds that there are any topic that belongs to hospital bed sensors, be it 1 or 2, it will go and route through this action. And over here in the action, we would like to choose DynamoDB. All right, there's two options for DynamoDB and V2. So we want to actually split this data into multiple columns. So if we choose DynamoDB, we have to use Lambda to actually preprocess the data. But since we do not need any preprocessing, we can just directly choose DynamoDB V2. So we'll split the message, the content of the raw message in JSON to multiple columns automatically for us. So we choose our table name, the sensor table, and then we choose our IAM row. And if everything checks out, we can click next. All right, now we review. So the SQL query is correct. Our actions is DynamoDB V2, and then we create. And there we go. This is our bed sensor table. Now let us simulate the data transfer from our IoT device. All right, I will run the Python script, which I have shown earlier. There it's starting to publish this data. So if we check in our bed sensor table, we go to export table items, we can see that the data is actually coming in. So we have device ID, date time, and then this actually is the same as how data will come in and get routed to the DynamoDB in real life if we are to use an actual IoT device. So you can see it's actually coming in the data. And now I would like to show you how we actually set up the SNS to notify the subscriber. So over here, we first have to go and create a topic. Now we will choose standard because standard actually supports more protocols such as SQS, Lambda, HTTP, SMS, email, and so on. So we give our topic a name. Let's call it high time. And we create the topic. Now the topic is created, we can go to create subscription. So the subscription is able to allow the users to subscribe to this topic. Over here at the create subscription, we have our topic ARN, and then what kind of protocol that we want. So over here we choose email, and then we choose an endpoint. So the endpoint is sort of like the subscriber to this topic. So I put my own email over here, and then we go to create subscription. And then the subscriber has to confirm the subscription. So over here, you can see we need to confirm the subscription. So to the topic, and then we choose confirm subscription. And AWS will notify us that we have confirmed our subscription. Now moving to the topic. So over here, we can see our high time topic, and we have to go back to IoT core to route this data to the SNS. So whenever a patient has recorded a high temperature, for example, we would route this to SNS, and SNS will send the notification to our endpoint or our subscriber. So over here, the same with how we set up the rules. We again go to create a rule. We call this high time notification, high time noti, and then we click next. And then again, we would like to set the SQL statement. So over here, we can select the device ID, the temperature, and the date time. So from whichever topic. So over here to demonstrate, we choose the topic from the first device. So hospital bed sensors 1. And then we would like to set the condition. So where condition is the temperature more than 38. So once we confirm that our SQL statement is correct, we click next, and then we choose the action that we want. So this time we choose SNS, and then the SNS topic is high temp that we just created, message format is raw, and then we choose our IAM role, and then we click next, and we review this role that we just created. If it's correct, then we can move forward. So we actually have already created a rule. So we would like to test this, whether it works. So we go to MQTT test client in IoT core console. We choose to publish to a topic, and then the topic is hospital bed sensor 1, and then we would publish this message. So the important thing here is the temperature. We set it as 38.5. So we would like to see if this actually triggered an SNS service. And if we go to our inbox, we can see that a new AWS notification message has been received by the subscriber. So the device ID, Smart Hospital Bed 01, and then the temperature is 38.5. And this is how we set up the SNS. Thank you.
So I'm going to show how you create an S3 bucket, because first you need the DynamoDB table, and then you need the S3 bucket. Both of these are storages, but we need Glue in the middle to pull the DynamoDB to create the table. We'll search for S3, and then we just click into S3. And now when you're in this page, this will be the list of the buckets that we currently have. So we just create a new one. And now for our project, because we have two different services that needs two different buckets, meaning we have to create two separate buckets. But for now, I'm just going to create one. This bucket is for AWS Athena. So I'm just going to name the bucket for Athena. Now I'm just going to scroll down and create a bucket. Now once the bucket has been successfully created, and see from give a will also be empty, because since we just created it and there's nothing inside, so now no object inside because it's an empty bucket. So go back, and then we create another bucket for SageMaker service. So I'm going to name this bucket for Sage. Let's go down and create the bucket. So now we have two separate buckets, one for Athena and one for SageMaker. That's it for creating the S3 bucket. So now we're going to create a Glue service. First, you have to create a crawler to pull the data from DynamoDB, and then the job to pull the data from the data catalog is a Glue to put into S3 buckets. Okay, so first search for Glue, open the page. Now in this page, we go to crawler, and then we have to create a crawler. Click on create crawler, and then first we name the crawler. I will name it Glue service. Then we create it. The button is here. Click next. Click on not yet, and then we have to add a data source. Since we're pulling the data from DynamoDB, so we choose DynamoDB. The table inside DynamoDB to just add sensor data, and now we just add the DynamoDB data source. Once you created it, we click on this one, and then we click on next. And now for the role, because we haven't created a role for this Glue yet, we have to create a role. We just name it Glue service role. This name can be anything. This is just to name the role. It doesn't have to be exactly the same. Could be anything. Once I created the role, I want to attach permissions into this Glue service role. I can click on view. It will open up a new tab. Right now in this page, we only have two permissions. But since we want to use the S3 permission and also the DynamoDB permission, we add permission, attach policies, and then we look for policies. First is Dynamo. This is Dynamo enter. And then we include this one, Amazon DynamoDB full access. And now we clear this filter first, and now we search for S3. Amazon S3 full access, we also take this one, and then we add permission to these two permissions into our role. And now since this, we already have the roles that we need, we just go back to the page before, which is this one, and then we click on update. Now it's updated, we can go next. Now the output configuration, since we want to output it into a Glue catalog table, we haven't created a database for it, so we have to create a database. Add a database. We'll open up a new tab, and then in this tab, we just create a new database inside for Glue. We just name it Glue service. The create database button here, and now Glue service will be added. Glue database will be added. So this database is here now. You can go back to this page. At first, there won't be any data. The database page won't be here. We have to click on refresh a few times, and then we'll see the Glue service here, and you just click on it. Now for the crawler schedule, because this is how we put it on demand. There's options for weekly, hourly, daily, but right now I'm just going to put on demand, and then we just click on the next button here. Now, this is your all these settings we just created. Just click on create crawler, and now once you created the crawler, we have to run the crawler. Just click on run crawler, and it will start running. And then we just have to wait for it to run finish. It's starting now, and now it's starting to run. We just have to wait for it to run finish. Now that you see the status is completed, means the crawler has been successfully completed. We can go to this data catalog database here, and then we look for Glue service, and then inside you will see our table with the data inside. That is a schema for the data inside the table. So basically the data has been inside already. So after pulling the data into the Glue service, we want to create a job into S3 bucket. So firstly, on the left side bar here, we click on ETL jobs to create a job. In this page here, we want to create a job for this. So first, this visual with the source and target, click on this one, and then the source will be the data catalog created just now. So Glue data catalog, and then the target will be Amazon S3 bucket, and then we just click on create. First, we click on data catalog table here. For this data preview, we want to choose the database where the data in the Glue that you want to be pulled from. So we choose Glue service, and inside Glue service, the table will be best sensor data. So let's click on this, and then this is done. We just go to S3 bucket. So there will be some differences here depending on this Athena JSON format, and then the target location will be our Athena bucket for this one, bucket for Athena. So I will just click this, and then I choose the button to choose this here, and then this will be all for Athena. If you want to create a job for Athena, and then if you want to create this job for SageMaker, the output format will have to be in a CSV file because our SageMaker service reads the data in a CSV format. So we choose the CSV format, and then we choose the target location as the bucket for SageMaker. Bucket for SageMaker, we click on this, and then we click on choose, and then this will be this settings will be for SageMaker, but for SageMaker, because we want only some of the columns instead of all the columns, so we click on the middle one, the time mapping, and then in this one, we do not need the time, the date time, so we drop it, and then for question 4, there will be struct with two variables. One is emission date and reason. We do not need the date, and we do not need the device ID. We only need the reason, and then the posture, and then completion on bed variable, temperature, and health status. All this is needed for our prediction model. And once that is done, this will be the settings for our SageMaker bucket. But for the rest of the video, I'm going to explain what we're going to do for Athena service. So I will be extracting this job, creating this job for Athena. So I will just go back to the original. I will not drop any tables, and then I will go click on the tree bucket, and I want to export in JSON for Athena. The target location also I will choose for. Okay, now I just choose it. Now the settings is done, and now after this, all the instructions later on will be the same for both SageMaker and Athena. But this process I'm just going to do it for Athena because I need to proceed with the process. So I'm just going to choose a sample which is Athena. So first, we just click on job details. We have to name our job. I will just name it Athena job. Now I scroll down. IAM role you can choose to be the same one just now, which is full service created. And then we scroll all the way down, go to advanced properties. And for this script, if this script is untitled, you just have to name it something else, like anything. But for this one, it auto named it for me, just in case it didn't name for you, you have to name it. And now once that is done, save. Once that is done saving, you click on this runs tab, you'll enter this page here. We want to run this job to pull the data from Glue into S3. So we click on run. And then the process of the execution will be shown here, running here. So we just wait for it to run finish. So now as it's shown that it's successfully finished running, we can check this out by going to our S3 bucket to see if the data is in our S3. This one is for Athena. So we search for S3. We go into the S3 bucket page. And then in this list, we choose, since we drag the data into Athena bucket for Athena, click on it. And then it is shown here that the data has been pulled inside into the S3 bucket. Now I can show you what's inside the file. I'll just download it to open it in my local system. So the file that I downloaded, I opened it in a notepad. And you can see here the data has been successfully pulled into the file that's now downloaded. Yeah, the file that's now downloaded. And the data is in here. This will be used for Athena. This process will be the same for SageMaker. Once we pull the data into the bucket for SageMaker, the data will be shown as well inside. Right now, we did not create a job for it yet, but the process is similar as I explained just now. So that is all for Amazon Glue service to pull the data into the S3 bucket from the DynamoDB table.
Now I'm going to demonstrate how to configure an Amazon antenna service. So first of all, at the AWS console here, type in the antenna and click on the antenna service. Then it will direct us to the antenna console. Then we can click on this create and the S3 bucket data. Then it will request us to create a new table. So I just put in the table name called patient table. Then for the description, I just leave blank because it's optional. Then we proceed to the database configuration. So if I did not have an existing database, I can click on create a database and just put in a database name. But in my case, I will choose an existing database, which is the patient DB. Then proceed to the data set. I will click on the browse S3 and click on the patient statistic, which is the bucket we store all the data set. And we click choose. Then we move on to the data format. In the data format, all the thing will remain as the default one, just the file format will be changed to the JSON. After that, we move on to the column detail. In the column detail, we need to configure the column name and the column type based on this screenshot, which I get from the DynamoDB data. Then user can create it by typing the column name one by one, adding the column name, choose the column type. But in my case, I will use this bug add columns function. Then I copy in this line, paste it here and click on add. Then all the attribute will be added in. We show in here, and I just pull to the bottom and click create table. After creating the table, we can choose the database here to the patient DB. Then the patient table we created just now can be viewed by clicking the three dot and view the table. Then the result will be shown down here. But this result will be shown only 10 results because it's limited to 10. If we deleted this limit to 10 and we click run again, all the data set will be shown with total of 500 data set. However, the data set is not sorted. So in order to sort the database, we can use this line, adding in this line, order by the device ID. Then we click on run again. Then all the data set will be sorted by the device ID. Then we can move on to the next page, so by device ID. In order to have this query, we can click on this create and view from the query. Then we can just give a name for this view, like sort patient table view. Then click on create. Then the view here will have the patient table view, which we created just now. Then we also can click on this three dot and preview the view and delete this limit to 10. Click on run. Then all the data set will be sorted. So that's all for the demonstration for Amazon antenna. Now I'm going to demonstrate how to configure an Amazon quick site. So first of all, in the AWS console, we type in the quick site. Then we choose this quick site service, and it will direct us to the quick site console. But if you are first time using this quick site, it will request the user to create an account. But in my case, I already signed up for an account and I already logged in. So this is the interface. We can start to create our dashboard by clicking this analysis. Then click on this new analysis. Then below is the dataset that's already assist. But in my case, I'm going to click on the new dataset. Then I also click on the antenna because I'm using antenna to display the dashboard. Then I just need to give a data source name. It will be called the patient antenna vision. Then I click on the create data source. Then after that, it will request us to select a database. So in our case, I just select the database that we create in the antenna called the patient DB, and also the table we create in the antenna, which is the sub patient table view. And we click on select. Then after that, we just need to check this import to Spike for quicker analytic, and then click the visualize. Then it will pop up this thing. Then we just select the first one and click on create. Then the user can create the visualization based on their interest. But for example, I will create a line chat. Click on the line chat. Then I put in the date time. Then I also put in the temperature as a value. And also I put in the device ID as a column. But we have a 5 device ID, so I need to do some filter. Just click on the filter here and add the filter. Filter by the device ID. Then I just select the smart hospital bed 1, the device ID 1. Then I click on apply. Then only the device ID 1 result will be shown the temperature. But in order to make it look nicer, we can click on this format vision to format the data and the graph. We can make the word look more nicely, and also the y-axis. We can click on the automatic base ring, which the temperature will be in those range. And those missing data, we can click on the continuous line to make it look more nicer. And we also can do some sorting for the date and time, for earlier time to the late time. So basically, This is just how we configure a visualization. Then after that, we can click on this icon here, the export, to export this dashboard as print or generate as a PDF or view downloads. So that's all for the demonstration to configure the Amazon quick site. Now I'm going to show the dashboard that I created in the quick site and being exported out as a PDF. So for the first visualization that I created is the temperature against date time line graph, which used to show the patient temperature on the device ID Smart Hospital Bed 1 having what temperature at what date time. Then for the second visualization is to keep track of the sleeping posture of the patient at what date time. Then the third visualization is to keep track is it the patient is on bed. So if the patient on bed attribute, the value here is 1, mean the patient is on bed. But if the patient on bed attribute here, the value is 0, mean the patient is not on the bed. Then the last visualization is to keep track of the sleeping posture of all patients, like the device ID 1, 2, 3, 4, and 5, having what sleeping posture.
So now we are going to demo the usage of Amazon SageMaker in build, train, and deploy the models. So first of all, let us search for Amazon SageMaker here. So it's a SageMaker. Then we click on it. Then since we are not going to use Studios, To-Do Labs, Canvas, those things, so I'm going to just use Jupyter Notebooks. So we click on this notebook at the left menu bar, click the notebook instances, then we click on create notebook instance. So for the notebook instance name, I will just put it as notebook. And, okay. So the instance types, please prefer that you choose this at T3.medium or T2.medium since they are both free for the free tier versions. And for these permission inclusions, we better create a role using the role creation wizards. Since I assume most of guys are new to this, so we assume all is the first time up. So for the role name suffix, we just simply put it. I put it as notebook ml.role and select persona. For this role permissions, we just custom role setting. Then click next. Then here we got asked us to configure the new role rights. So first of all, we give the S3 for access first. Next. Then for the add additional policies, I think we can skip that. Review roles and then just submit. So the role will be created. So as on now, the role has been created, but we have to go to the roles to add the SageMaker full access. So add permission here. So SageMaker full access. Add permission. Okay, so now we go back to the SageMaker. Go back to the notebook here. Okay. So no custom encryptions. So we just create the notebook instances. So that's all for the creation of notebook. Okay, so now the notebook ML has been created. So the status is in service. So for the notebook that not in service or not working, it will show stops. So now if I'm going to use Jupyter Labs to start creating my codes to start scripting. So now we wait for the notebook, for instance, notebook ML to open. So now our Jupyter Lab has been opened. So now we create a notebook file. So I will going to use the TensorFlow W2, TensorFlow 2. So I will start scripting for it. So since I've already have the code, I will just copy and paste. So this will take some time for the code to run. Okay, from here, I successfully import the S3 file that we mentioned before that we're going to use for this SageMaker. So here is the setup. Set up S3 clients using the Boto tree libraries and also specify the S3 bucket and folder path. So if you have the bucket names, so you just rename here. And for the folder key is your like subfolder. You may just include what subfolder you have, or if you don't have any subfolder inside your bucket names, inside your buckets, you may just like directly put it as blank like me. So now I'm going to remove the non-available data, split the data set, and then make a one-hot encoding on those category data. And scalar for the numerical data. Now we're going to split the set to train set test set, and we start to train the logistic regression models. So since this is just demo video, I will not be fine-tuning for the models, but I can show you the results. So it can predict healthy, 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 healthy. With these false predictions, unhealthy, unhealthy, the false prediction, and the correct prediction. So it's actually a quite good results. I think some overfitting for what is happening, but that's not matter. Then after that, we will be going to like save the model tree into our S3 for the bucket name. So yeah, so the S3 has been saved into a bucket named train buckets. This train bucket actually no need to be exist in your S3, Amazon S3. If you just name it, it will auto create for you inside the Amazon S3. So now let us open the Amazon S3 and see whether the model is safe or not. So we click on the train bucket, my model, click again. Then you can see the model.job is safe on the creation times 6 a.m. is the current times. So yeah, that's all for my demonstration on Amazon SageMaker.